our model is 3 times the middle. 3 times the middle integer. We're told that 3 times the middle integer is, here's our equals mark, 13 more than means we're going to add 13 to the sum of the first and third. Sum means we add the first and third. So our model is 3 times the middle is equal to the first and third added together, then plus 13. What stands for the middle integer? Well, looking back at our labeled parts, we see that the middle or second integer is x plus 2. And so on the left-hand side, we write 3 times x plus 2. Our first integer, we're calling x. Our third integer, we're calling x plus 4. And so, you notice I put the x plus 4 in parentheses, so I know that that came as a package. So I have the first plus the third in parentheses added to 13. And so we've accomplished our first step, which is to translate this to an equation. We have 3 times the expression x plus 2 is equal to, in parentheses, x plus the expression x plus 4, then add 13. All that's left is to solve. And so let's do so. We will simplify on the left by multiplying 3 by the parentheses, and we get 3x plus 6. On the right, combining the like terms in parentheses, we get 2x. We add 4 to that, but the 4 is going to be added to 13, and that gives us 3x plus 6 on the left is equal to 2x plus 17 on the right. Then we sort laundry. Eliminate the 6 by adding its opposite. We add negative 6 to both sides. 3x plus 6 plus negative 6 is equal to 2x plus 17 plus negative 6. The 6's on the left cancel, leaving us with 3x. We combine the 17 and negative 6 on the right so that we have 3x is equal to 2x plus 11. Then, eliminate the 2x by adding its opposite. We'll add negative 2x to both sides of the equation. That gives us, on the left, 3x plus negative 2x, which is x, and on the right, 11. And so our answer is 11. Well, that says that we have x is equal to 11. But remember that the equation had a first, a second, and a third. Our first integer was x. We just determined that x is 11. And so, x is equal to 11. The second integer is x plus 2. Since x is 11, this gives us 11 plus 2. And 11 plus 2 is 13. The third integer is x plus 4. Since x is 11, we have 11 plus 4, which is 15. That means that we have as our first integer 11, as our second integer 13, and as our third integer 15. Now to check these, we must be sure that, first of all, they satisfy the words that we began with. Find 3 consecutive odd integers. Are these consecutive odd integers? 11, 13, and 15. Yes. Then 3 times the middle integer must be the same as 13 more than the sum of the first and third. So let's go to our check format, and I have rewritten this as 3 times the middle is equal to 13 more than sum of first and third. 3 times middle is equal to 13 more than sum of first and third. Now, we figured out that the middle integer, or our second integer, is 13. And so we have 3 times 13. The first integer and the third integer are 11 and 15, and so I have 13 more than the sum of 11 and 15. Now 3 times 13 is 39, 11 plus 15 is 26, and 26 plus 13 is also 39. And so the answers that I've determined, 11, 13, and 15, are correct. Recognize that finding just the answer for x is not sufficient. We must finish the problem and get the answer for the entire question, which is for all 3 of the integers. Now let's look at an application that is not consecutive integers. Under our applications, we're going to look at one example, and we're going to relate it to classes at RCC. The example reads, last summer there were 7 more students in Math 102. Last summer there were 7 more students in Math 102 than in English 101. Last summer there were 7 more students in Math 102 than in English 101. A total of 165 students took the courses. A total of 165 students took the courses. How many students took each course? How many students took each course? This time, we do not have the word is in the problem anywhere. This means that we're going to have to use some more reasoning power rather than simply direct translation. Notice that we're told that last summer there were 7 more students in Math 102 than in English 101. 7 more means we're going to add 7. So it seems that the number of students in Math 102 should be something add 7. Something add 7. Well, let's make the number of Math 102 students be x add 7. There were 7 more students in Math 102 than in English, and so x plus 7 reflects that 7 more. There were 7 more Math 102 students than English 101 students, so the number of English 101 students must be simply the thing that we based the x plus 7 on, which is x. The number of English 101 students would be just x.